is to keep you cool and comfortable. Even when the temperature's the fascinating science behind its cooling magic. So let's roll up our sleeves and get started. The fundamental working principle of an air conditioner is simple. A cold refrigerant is continuously passed through the conditioner and a fan blows air. That makes down its key components. At the heart of the system is the compressor. Think of it as the engine that drives the entire cooling process. The compressor pressurizes the refrigerant, transforming spiral type of compressor is used. As the gas enters the spiral, space becomes crowded and the gas is compressed. After being compressed, the gas is discharged from the pipe above. This type of compressor is very energy efficient and makes less noise. Condenser, this component is kept outside of your home. As the high-pressure refrigerant gas flows through the condenser coils, it releases heat into the surrounding air and condenses into a high-pressure liquid. This crucial step is what allows your air conditioner to expel the unwanted heat from inside your home to the outdoors. The refrigerant is now cool but at high pressure, so to lower the pressure we introduce another important component called the expansion valve. This component might be small but plays a crucial role in the cooling process. As the high-pressure liquid refrigerant passes through the expansion valve, its pressure drops suddenly, called a thermostatic expansion valve, or TXV. It is quite similar to the expansion valve we saw earlier, but this time this valve consists of a bulb that controls the needle. The bulb is separated from the main refrigeration cycle using a diaphragm. The bulb is placed in contact with the evaporation coil's exit. When the bulb is heated, the refrigerant inside the bulb will expand. Then it will exert pressure on the diaphragm, and the needle will move down. When the needle moves down, then the restriction is widened, and when the needle moves up, the restriction is narrowed. When the refrigerant inside the evaporation coil is not converted completely into vapor, then it will not be superheated. The bulb will immediately sense this low temperature, and the liquid inside will contract. Then the pressure on the diaphragm will also decrease, causing the needle to move upward and narrowing the restriction. A narrow restriction causes a good amount of pressure drop, which will cause a temperature drop, thus it can absorb a good amount of heat due to its low temperature. This will make sure that all the liquid is converted into vapor. Due to the low temperature of the evaporator coil and the continuous flow of cold liquid, water condensate is formed, which is collected and removed through a pipe. We hope this video helped you understand the working of the air conditioner and